Good morning. So this is Unit 2, Day 5 notes. You guys are almost there. We're just going to go over graphing our trigonometric functions again when we have transformations. So this is a good review of our Unit 1 transformation section. Please try this warm-up. And I'm going to help you guys with what does cosine of x look like compared to what does negative 1/2 cosine of x look like. So remember our x, we're going to go around the unit circle, and this is going to be our radians. We start at 0, and then I'm going to do pi over 2, and then pi, and then 3 pi over 2, and then this is 2 pi, back to 2 pi. Cosine is our x values, and along the x-axis right here, this is going to be, this point is at 1, 0. This right here is at 0, 1. This right here is at negative 1, 0. And this point down here is at 0, negative 1, right? I'm just going to, I just want my cosine, which is my x values. I just care about the x values. So when cosine is at 0, my x value is 1. When cosine is at pi over 2, my x value is 0. And then negative 1, and then 0, and then we're back at 1. So I'm going to plot this first in green, and I'm going to say that 1 is like maybe right here. Okay, this is 1. And this right here, this reddish line is going to be pi over 2. So this one is going to be pi, and then 3 pi over 2, and then 2 pi. I don't know if I could have spread it out more, probably not. All right, this is my x-axis. Make sure you're always labeling your axes. This is my y-axis. And then what I'm going to do is I'm going to show you what this is going to look like. Well, first let's graph it. So when my radians is 0, my value is 1. At pi over 2, I'm at 0. At pi, I guess this is going to be negative 1. So I'm going to be down here at negative 1. And then 0, and then I'm back at 1. And remember, they're kind of curved. Okay. It's not a V, it's a wave. So it kind of looks like this. Now let's do cosine 1/2 of cosine of x. So basically, cosine of x is 1 when we're at 0. Cosine of x is 1. I'm multiplying it by negative 1/2. So 1 times negative 1/2 is negative 1/2. At pi over 2, my cosine is 0. Negative 1/2 times 0 is still 0. At pi, my cosine is negative 1. So I have negative 1/2, but my cosine is negative 1. That becomes positive 1/2. So it looks like we're flipping it. At 3 pi over 2, my cosine is 0. Negative 1/2 times 0 is just 0. And then when my cosine at 2 pi is going to be negative 1/2 times 1, so it's just going to be negative 1/2. And I'm going to graph it on this so you guys can see what the difference looks like. I'm sorry, I need arrows because these go on forever. So I'm just going to put those arrows. They go on infinitely. Okay, now let's graph the negative 1/2 cosine of x. So it looks like at 0, we're at negative 1/2, which is right here. At pi over 2, we're at 0 again. Oh, it should have gone through. At pi, we're at 1/2, positive 1/2. And then at 3 pi over 2, we're at 0. And then at 2 pi, we are at negative 1/2 again. So something like this. And I'm going to do the opposite. I'm just going to connect the dots. Put the little arrows on both sides. We need those. And this is going to be our transformation, negative 1/2 times our cosine of x. That's what happens. So our amplitude on this one is equal to 1/2. Remember, that's the distance from our midline or our line of symmetry to the max or the min. That's going to be 1/2. So that's what the 1/2 does. The negative, if the number in front of my cosine is negative, that's just going to flip it across the x-axis. Okay, so it started at 1, now it's going to start at -1/2. Alrighty, let's look at this. I'm just going to define it for you. So I think on your paper it has like a big capital A. Amplitude is the absolute value of A. Okay? So the amplitude, this is a definition, remember, is the distance between the midline and the maximum value. So the amplitude is going to be the number in front of our trig function, a sine of bx, a cosine of bx. So right here, y equals 3 cosine of x, our amplitude is the absolute value of whatever's in front. So the absolute value of 3 is going to be 3. Given y equals -17 sine of 3x minus 5, we don't really care about this for the amplitude or this. All we care about is the number in front of your sine and multiplied by your sine. And my amplitude is the absolute value of -17, which is just 17. Okay. What if a is negative? If a is less than 0, if it's negative, there is going to be a vertical reflection. So just write that, vertical reflection. This means that it's going to reflect across the x-axis. Okay? Transformations and horizontal dilations. So we're going to look at what happens when we have sine of x compared to sine of 1/2 x. The 1/2 is not in front of my sine, so this is not going to be an amplitude change. Just remember the unit circle. I'm going to draw your points for you. Remember, this is over 1, up and down 0. This is only up 1, so 0, 1. This is to the left 1, and up and down 0. This one is, we're not going left or right. It's going to go straight down 1. So this is 0, -1. And remember, sine is our y value, so we only care about the y. Sine at 0 radians is right here, and our y value is 0. Sine at pi over 2, this is pi over 2, our y value is 1. Sine at pi, our y value goes back to 0. Sine at 3 pi over 2, our y value is going to go down. It's going to be at -1. And then at 2 pi, we're going to go back to 0. Even if I go around the circle again, I can go around again. But at 4 pi is going to be right here, and sine is going to also be 0. Okay. I'm going to plot that for you. This is when our radians is 0, and I'm going to make this one, I guess, doesn't really matter, and this is -1. And I know that at the origin, sine is 0, and then this is going to be pi over 2, pi, (3 pi over 2), 2 pi, and we're going to keep going if we have to, right? At 0, I know it's 0. At pi over 2, we're at 1. At pi, we're at 0. 3 pi over 2, we're at -1. And at 2 pi, we're back at 0. So remember, these are curved, not V's. And this is 1 full revolution of sine of x. Now let's look at 1/2, or sine of 1/2 x. Okay, well, the easiest thing to do is just use my chart. When I substitute in 0 into the x, I get 1/2 times 0. Well, that's still 0. I don't know what happened. So sine at 0 is still 0. Let's use this color. Okay. And then when we substitute in pi over 2, this is asking us what is sine at 1/2. We're substituting in pi over 2. Well, pi over 2 times 1/2, this is now pi over 4. What is sine's value at pi over 4? This is going to be the square root of 2 over 2, right? Let's check out pi. So sine 1/2 times pi is pi over 2. And sine's value at pi over 2, this is pi over 2 right here, is at 1. I want to change colors, but I don't. Okay, sine, we have 1/2 of, this one is 3 pi over 2. So 3 pi over 2, this is going to be 3 pi over 4. And at 3 pi over 4, this is pi over 4, 2 pi over 4, 3 pi over 4. Sine is my y values, and they're still positive. So we're going to be back at square root of 2 over 2. Positive square root of 2 over 2. At 2 pi, it's going to be sine of 1/2 of 2 pi. Oh, we're barely getting to pi. Okay, so sine at pi is my x, is my y values, and that's 0. Let's go to 4 pi then. I know that sine at 1/2 of 4 pi, that's 2 pi. So 4 divided by 2 is 2 pi. Sine at 2 pi is 0. So that would be make one full revolution. This would be one full revolution. Let's see what it looks like. So I know that I'm still starting at the origin. I'm still going up to 1, down to -1, but slower. So at pi over 2, I'm at the square root of 2 divided by 2. And the square root of 2 divided by 2 will be something like this. At pi, I know that I'm going to be at 0. I'm sorry, at pi I'm going to be at 1. So I'll be right here. So this is pi, I'm going to be at 1. At 3 pi over 2, I'm barely going back down right here. At 2 pi, I will be at 0. And it won't come back up until 4 pi. So this is only one part of my revolution. So this is 1, 2, 3, 4. 1, 2, 3, 4 pi will be right here. This will be -1, and then 4 pi will be right here. So do you guys see that it's being stretched? My sine of 1/2 x is being stretched. My period is going to be different. So remember, my period is 2 pi divided by the absolute value of b. And my b is 1/2. It's a fraction. So this is going to be 2 pi divided by 1/2. We never divide by fractions. We're going to say 2 pi divided by 1/2. But what we do is we flip it. We multiply by the reciprocal. So 2 pi times the reciprocal of 1/2 is 2. That means that we're going to make one full revolution in 4 pi. And that's true. That's what we did. So my original period times my horizontal scale factor. I'm going to write that down for you. This is my original period. And then this is going to be my horizontal scale factor. And that gives us our new period. This is our new period. I crossed it out. Okay. So let's find, let's do this one. We're actually doing two things. Our amplitude is going to be this right here. So instead of going between 1 and -1, we're going to go between 2 and -2. So this is my amplitude. And it's going to be cosine of 2x. So how is that going to change our cosine? It looks like, remember our period is, the formula is 2 pi divided by b. Our b is going to be this 2. 2 divided by 2 is 1, so we still have a pi. So we're going to make one full revolution within pi. So let's fill this out. We know that if this is pi over 2, then this is going to be pi right here. I'm just going to spread it out a little bit. We know that our cosine starts at 1. So if 1 is right here, I'm going to make 2 right here, -1, -2. And ours is going to start at 2 because our amplitude is 2. And then we know that it's going to cross the x-axis right here. At pi over 2, usually at pi, we would go down to -2, but we're cutting it in half. So now at pi over 2, we're going to go down to -2. And then pi is one full revolution, so we're going to go all the way back to where we started. And this is going to be our function, our graph of 2 cosine of 2x. I want you guys to try this one. I want you guys to try these. All right, guys, so try the rest and let me know if you have any questions in class.